Hello everyone, welcome to another video here from toysandphysics.com. I'm going to be working on something that I found on Reddit. I found it quite interesting and fun to solve, believe it or not. I actually enjoy doing this type of things. It's a physics problem that states something about a car. It really got my attention because somebody was asking for help with this. I thought, yeah, why not? Let's give it a try and see if I can if I'm up to the challenge, right? Of course, I'm going to give a solution here. I'll try to explain myself. The intent, of course, is I hope this will be helpful for anyone struggling with this type of problems. This is a motion along a straight line type of problem. We're going to talk about acceleration, initial velocities, position, stuff like that. So hope you enjoy it and find it useful. If, by the way, you find a mistake or you have any feedback for me, I'm more than open to that. I always enjoy and welcome any comments you have. Let's get started. The problem statement, it's not here, but it basically says that there's a car that's in point A at point A that's at rest. It starts moving from point A to point B. We have the position of point B, which is 15 meters from point A, because point A is 0, the velocity is 0, the time the clock starts ticking at point A, so it's 0 as well. But we don't know the velocity here. We also know that it takes 2.4 seconds here for the car to get from point A to point B. And the question, and by the way, before going to the question, the problem statement gives a key, which I think it's important, and that is that the acceleration, once the cart starts moving from here to here and then to here, that's the acceleration is constant. Okay, so that's key. I think that's important to highlight. I'm going to develop more on that topic, but for now, just want to highlight that. And the question pretty much says, how long once the car reaches point B, how long will it take for the car to reach point C? If point C it's at 30 meters from point A or 15 meters from point B, right? So I just added those here, and the question is we need to know um, the velocity in B. We don't know as well the velocity in C. We don't know the time that it will take for the car to get from point A to point C. That's TC, the time at C. The acceleration, although it's constant, we don't know it. And the question we want to answer is, what's the delta in time from C to B, or B to C? Maybe I put that wrong, but it's the time from B to C, right? How long would it take from B to C to the car if it's accelerating constant, if its acceleration is constant, and it'll travel another 50 meters. Okay, so let's get started with the explanation that I have for this problem, the solution that I want to propose, and hope you find that helpful. So the first thing would be to remember, that's why the highlight I made, that the acceleration is constant, and that will help us if we before that actually. What I want to do here is to divide the problem in two, and that's for I'm going to solve everything I can solve from A to B. So I'm gonna check if I can find B and B, then the acceleration of this portion of the problem. And once I have those, I can go from B to C, right? So this top portion of the page, it's for A to B, right? So let's go with that, and then we'll go from B to C, right? So the acceleration from A to B will be the same from B to C. So that means that the acceleration at any time, since it's constant, it's the same, right? It's important to say that because if we go back to the basics in terms of the definition of acceleration, we know that acceleration is just the difference in velocities from one point to another, divided by the time it takes for that velocity, those velocities to change, right? So that's BB minus BA divided by TB minus TA. Of course, these two are zero because we know those here. Those are zero, so I just cancel those, and we can simplify this to say that the acceleration will be the velocity in B divided by the time it takes for the car to reach spot B, point B. Okay. If we solve for velocity in V, we know that it'll be the result of multiplying the acceleration times the time in B. Okay. Now, if we follow this arrow here, we go to the average velocity concept. And again, average velocity is just defined as the ratio of the displacement, change in position from one point to another, to the time it takes for that change in displacement to occur. So if we put this in an equation, it's nothing more, nothing less than x in B minus x in A divided by t in B minus t in A. Again, these two are zero. We know that from the data that we were given. So if we simplify this, it'll be that the average velocity, and that's important, I'm going to make distinction there. The average velocity from A to B, it's equal to xb divided by tb. Now, we want to know the velocity in B, not the average velocity, okay? So that's important. But there's another equation that we can use that says that the average velocity at these 2 points, it's nothing more than the average of the velocities, right? The normal definition of average, which is BA plus BB divided by 2. That's a normal average that you would, normal average operation you would do for any average at all. So that's also the average velocity for A to B, right? Now, the interesting thing here is that we have now here B and V, and if we make 2 and 3 equal, if we just say those two are the same, which they are, we have this new equation here. So now we know that the position in B divided by the time in V equals the velocity in B divided by 2. And if we solve for B and V, we say now that our equation number 4, V and V equals 2 times the position in B divided by TB. Okay, I hope it's helpful so far, and not. I know it sounds like a tongue twister, XB, TB, BB, stuff like that, but I'm just trying to make this as simple and useful as possible. Okay, so that's our equation number 4. And if we go from equation number 4 here, by the way, all these two quantities here, we have them, so we can know the value of V and B, right? So you could just replace numbers and start doing the calculations. I'm not going to do that here. It's going to take some time, but I just want to present the equations for the solution. Okay, so if you go from 4 to number 1 again, and if you did the math here and the calculation, you can get A straight from here, but I'm going to do some additional math here and say BB equals 2XB divided by TB, and also BB here equals ATB. So if I just make these two 1 and 4 equal, I can solve for A, and now I know that A equals, that's acceleration, and again, which is constant and the same during the entire trip of the car. I now know that the acceleration equals 2 times xb divided by tb squared, and that's the result of solving for A here when I decided to make this equal to this. 1 equal to 4, 4 equal to 1, whatever you want to call it, that's the equation you get, and that's what I will call equation number 5. Okay, so that so far has given us the velocity in V and the acceleration from A to B. Now, the important thing here is that we now know this is constant. This acceleration here is constant, so it should be the same from A to B and then from B to C. So we can use this equation later here um, to to replace some terms, and that will be valid because the acceleration is constant. So that's the key, and that's the importance of having the acceleration constant in this case. Okay, so like I said, this top portion here was for A to B. Now let's go to B to C, which is the the bottom portion of the page. And again, the concept and the mechanic will be the same. Let's first of all go back to the acceleration from B to C. Then we'll go to the average velocity. We'll do exact same thing here that we did here. Um, and after some math, we'll be able to just solve for TC. Let me just give a brief explanation of this, right? So again, the acceleration from B to C will be BC minus BB divided by TC minus TB. That if you solve for B in C, will give you this equation here, which I call equation number 6. From here, follow this arrow here, and same concept, same thing, same idea we did here. Let's do average velocity, which is the ratio of the displacement to the time it took for that displacement to happen. And also the definition of average velocity, BB plus BC divided by 2. If you make those two equal, you get this. And this equation number 7, I just solved that for BC. From here, let's go to this. Let's follow this arrow. If you replace these two, BC and 6 and 7, if you make those two equal, you get this equation you see here. Do the math. Just make sure you solve for TC, because now that's what's interesting here is that this equation, the only thing that you don't know about it, it's T and C, right? But everything else, you have it. You have B and B, you have acceleration, you have T and B, you have X and C, and everything that's in here, you have it. So just make sure that you solve this for T and C. So after doing that, I got this equation here. And by the way, this is just one of the steps that I made to solve this equation for a TC. If you were wondering, in case you checked this math, what's this? I did a silly mistake here when I was solving this equation. I forgot to multiply this by BB. It's something that happened, but that's what should happen here. So that's what it says here: T in C minus T in B, which is this term here. Okay, so just in case you were wondering. Okay, and well, after arranging this to make this this equation here. Again, I'm not going to do the numbers here on the math here, but the numbers I got are here. The acceleration I got was 5.2 meters per second square. Then the velocity in V, it's 12.5 meters per second. Velocity in C, it's 17.7 meters per second. You can, once you have these two numbers, you can, and well, once you have the TC, you can use either 6 or 7 to get velocity in C. The results should be the same. And the time in C, I got it for almost 0.4 seconds, right? So that's 3.4 seconds is what it takes to the car to get from A to Z, right? But the question was this: what's the time length from B to C? So if you do that, it's just a matter of doing TC minus TB. I did that real quick here, and it's 0.99 seconds, 1 second more or less. So that's the solution for the problem. And like I said, the numbers I got, the results I got are here. Check them. Let me know if you have any feedback, if you have any questions. I tried to do this quite simple, useful, but at the same time try to explain. I just bring the equations and just replace and do this and do that. But what I try to do here was to kind of get to the solution by just by following a procedure there, right? So hope that was helpful for you. Let me know if you have any questions. If you want to find more interesting stuff, actually upload more content and new content every day to toysandphysics.com. That's the site. It's right here and also here in case you missed it. But toysandphysics.com, I'm uploading new, more interesting content. I try to make it engaging. I try to make it simple. Entertaining and useful, easy to follow, easy to use, easy to learn for physics students and everyone interested in this. And again, if you have any feedback, any questions, whatever, just let me know. I'm more than open to that, believe me, and I'll be happy to know more about you. Okay, so that's all for now. So thank you very much for your time and goodbye. Have a good one. Bye bye.